Okay, so where we left off was right about here. And then we completed it. So I'm going to just show you really quickly what we did. We set up our system of equations again, got the like terms together, and we found out a plus c makes 0x squared. So therefore, a plus c makes 0, and b minus 2c times this x makes 4x. So therefore, this makes 4. And these guys don't give us any constants because that's what our original integral had. No constants, okay? So we transfer this to our system of equations. And when I did it, I took the first one and subtracted the c and got c to this. And then I substituted this c in for that negative a and put it into that bottom equation, which then simplified to 2c plus b equals 0. And so now I have c's and b's, and I rewrote it over here. I took this equation, put it right there, and I took this equation, put it right there, and now I have a new system of equations. This time I used process of elimination, so I eliminated those. That left me with b equal to 2. And then I took that 2 and I inputted it right here, because that was easier for me, and set it equal to 0, and found my c equal to -1, and a is equal to 1. And so then rewrote the integral in this manner right here, and then took the antiderivative of each. So when you took the antiderivative of this one, it's this. When you take the antiderivative of this one, is this, which this seemed to cause a lot of confusion for some people. So I need to go over that really quickly. And when you take the antiderivative of this, and of course your plus c. So how does this come about? This comes about, you can think of it in two ways. If I do u substitution, I can look at this integral right here and go 2x minus 1 squared dx, and I can say u is equal to x minus 1, and du is equal to dx. And so then I would have this 2 integral 1 over u squared du. And what would that be? That would be, you would undo this power rule, so then it will be 2 divided by u times -1, or divided by -1 plus c, which then ends up being -2. And what is our u? It is x minus 1 plus c, which, ignore that plus c because that's going to go at the very end. And that is how we get this expression here. When I did my work, I didn't do u substitution. I kind of just did it in my head and undid this process. But whatever method you use that is correct, you would get this, okay? So that is the conclusion of case number 2. Now, case number 3. Case number 3. Again, we start off with this new problem right here, and then the first step is to factor. So we factor, and we get this. And then we'll notice that this is a linear factor, but this is not a linear factor. This is a quadratic, but this is not factorable. It is left as a quadratic. Unlike case 2, where I had a quadratic, but it's made up of linear factors, okay? So this one is an irreducible factor. So I can't reduce it down to linear factors. So that's what this case is, okay? This is irreducible factors in the denominator. So when you have a problem like this, then here you have 2 factors, and so therefore you will have 2 fractions, okay? And like usual, I'll put my a over here. And then for this one, for the x squared plus 4, I'm going to do bx plus c. Notice this is x squared, so I'm going to start with x to the first power, and I have to give it a coefficient. And then I go all the way down to x to the 0 power. Okay, so before we continue our work, let's say that we had a factor of like this, x cubed plus x squared minus 5. Let's just make that up, okay? And let's say that this is irreducible, okay? So what would we have in our integral? I would have x cubed plus x squared minus 5. And I would say ax squared plus bx plus c. That is how I would place it. Okay? All right, so it would always be one less than this, and then you would give each one a coefficient all the way until you get down to x to the 0 power. Okay? And if you notice, for this example, and actually all previous examples, this is x to the first, so therefore this was bx to the 0 power. So that is how we set these up. That's how we set these fractions up. Okay? So that's a separate situation, so we don't worry about that. That's just showing you. Okay? Now we continue the process for this problem. So what do? We try to do our common denominator process and simplify it. So a is missing, this one, and bx plus c is missing an x. And when we simplified it, you get this, and this is our numerator, right? And so now let's put our like terms together and match it up with our numerator, like so. And then we can set up our system of equations. So we have a plus b, this will be step 5, our system, is equal to 2. And c is equal to -1. And a is equal to 1. That's easy. So easy. So easy. So therefore, we can easily figure out what b is. If a is 1, therefore b is 1. And it's done. Yeah. So now we can solve or finish our case 3. And so I'm going to rewrite it over here. So I'm going to have the integral, I forgot, a is 1. So it's 1 over x plus, and then it said b is 1. So it's 1x, and it's, what is it? C is a -1. So minus c, minus 1. Minus 1, and I don't need that 1 really. That's just a distraction. All over x squared plus 4 dx. Okay, so now that we have that, this, what is this going to be? This is going to be natural log absolute value of x, and this looks like a doozy. So I'm going to break this up. I'm going to do this. Integral of x minus 1 all over x squared plus 4 dx. And then suggestions from my audience. Okay, so u substitution is a good one because I know if I make this my u, then my du is going to get me an x. But the only problem is I have this minus 1. So another suggestion? Two separate integrals? How would I separate as two separate integrals?
X over x squared plus 4 minus integral of 1 over x.
Yes. Yes, I would break up my fraction. So I can have x all over x squared plus 4 dx. And then I'll say minus integral of 1 over x squared plus 4 dx. Like that. And then I can use u substitution here. So I'll say u is equal to x squared plus 4. Du divided by 2 is equal to x dx, right? So this is natural log absolute value of x. Then if I do this, and hopefully we can think ahead, if you can quickly do this in your head, you know it's going to be 1 over u. So this is going to be natural log absolute value of x squared plus 4 after you do your u substitution. Okay, now this one is another doozy because I have this x squared here. This is not natural log. It's tangent inverse. So intelligent, yes. But the problem is tangent inverse is x squared.